Okay, good afternoon. I changed the title a little bit, but no one notices, I think. No one has read the program. That's okay. It's actually the same story. So I think those of us that have been writing about the Brazilian Amazon in the first half of the last decade usually started their papers with something like, Brazil is the country with the highest deforestation rates in the world. And to the surprise of some of us, at least my surprise, this is not true anymore. And I thought I'd tell you a little bit about some work that we're doing here at ZEF that is aligned with many other researchers who are trying to understand what has happened in Brazil. And what has happened is that we had this last peak in deforestation rates, or annual deforestation loss in Brazil in 2004. That was more or less at 27,000 square kilometers per year. That is about the size of the state of Brandenburg in Germany, so it's pretty huge. And since then it has been almost steadily going down to something less than 5,000 square kilometers this year and the year before as well. This black line that you see here is the effort of the environmental police in Brazil called IBAMA, and it's sort of the number of fines that they applied in the Brazilian Amazon for illegal deforestation. So it's somehow following the trend, but there was a peak in the year after 2004 that reflects the effort of enforcing deforestation law in the region. Before 2004, this fining activity or the enforcement of law activity was usually being associated with a very ineffective record. So still now, if you look at how much of the fines that are given out per year are actually being collected, it's less than 1%. So you would ask yourself, how could a system that does collect only 1% of the fine that are actually being given out, how would that system be effective in reducing deforestation? So in 2004 and 2005, Brazil, under the new government of Lula, introduced a series of reforms, governance reforms in the environmental policy sector, especially regarding the Brazilian Amazon. And they put up this program called Program to Combat Deforestation in the Amazon, PPCDAM. And then many things changed in the way how these policies were implemented. And since then we see this reduction in deforestation rates. There was a study in 2012 that showed how the sizes of deforestation patches was distributed and how that changed over time. So you have to imagine they have this monitoring system that takes pictures every month, and then they collect them, and then they know, 20% of the patches are larger than 20 hectares, some of them are 200, 300 hectares, and others are just 50 hectares or 20 hectares or even smaller than that. So what this shows basically is that the distribution of sizes of polygons, deforestation polygons, has changed over time. In 2002 you still had a pretty large share of deforestation polygons that were rather big, and then towards 2007, 8, 9, the total amount of large ones became smaller, and it looks as if the share of the smaller polygons became larger. But the hypothesis that this paper comes up with is that, those police people are going after the big guys, so now the big guys change their mind and they're doing just many small deforestation polygons instead of doing the big ones. So we have some sort of avoidance behavior, that's how they call it. Yeah? That's a hypothesis. So there's another hypothesis put forward by Pacheco and others is that we really have some sort of structural change going on in Brazil, that the agricultural frontier is stabilizing, and that the policies are working better, and that because of that the big guys stop deforesting that much, and only the small holders are continuing doing sort of slash and burn based small scale deforestation. So we took these two papers as a justification for asking two questions. One is, what is the deterrence effect of an individual fine? So what does this single fine applied in some region in the Amazon really reduce in terms of deforestation from one year to the other? There are some other papers who looked at that, but not at a very small scale. They just looked at the district scale. And then the second question is, does targeting these field operations to large-scale deforestation, which is what IBAMA has been doing in the past, does that induce some sort of avoidance behavior, sort of along the lines of dividing a big polygon up in many small ones? Okay, so this is how our data looks like. We just divided the whole Amazon up in about 11,800 small 20 by 20 kilometers pixels, and then we measured deforestation in those pixels. So when you see a green pixel here, then deforestation has been going down from 2010 to 2011. When it's a red one, it has been going up. And when there's a black dot, there has been a fine applied in that pixel, or more of them. So some of these are just several fines, but you can't see that there are many because the dots are so big. So this is sort of, we have this kind of data for 2 years, and it's really unique. I mean, you have to imagine each and every police officer that went into the Amazon had a GPS device and just took a point when he finds someone, yeah, he or she. So we know for what type of infraction, for what type of offense the fine was given out for. We know the size of the fine, and we know which operation, when it took place, and so on and so forth. So what we did is we divided this area up, and then we counted the points in each pixel. We counted the deforestation polygons, we looked at the size, and the idea is now to somehow measure the effect of a single fine. Now, obviously, where there's a lot of deforestation, there are lots of fines. So you have to find a strategy to compare one of those pixels that doesn't have a fine with one of those pixels that has a fine, and these two pixels should be very similar, so that you be able to extract some information on what the effect of the fine could be. And it doesn't really look intuitively in favor or against the policy. You see there's many black dots in areas where deforestation has been increased, and there are also some of the black dots in areas where it seems to have had some impact. So we did this so-called matching analysis, which is trying to pair up pixels that have been treated, that have received a fine, with pixels that haven't received a fine, using a set of factors. Now, there are many problematic confounding factors, or factors that kind of mess up or can mess up the analysis. And one is clouds. Deforestation is measured using satellite data, and this kind of satellite data is prone to clouds. And if you look at this is 2010 and this is 2011. It looks as if in 2010 nothing happened in that 20 by 20 square kilometer pixel. But then in 2011 there's a lot of deforestation patches in the same pixel. But then if you look where the clouds were in 2010 and where they were in 2011, part of this has probably happened here, but it wasn't detected. Now there's another deforestation monitoring system that's called ZEF in Brazil that comes more often, but it is not as fine scale as the other one, ProDES, that generated this map here. But if you merge the two data sets, you find that some of the polygons that only appear in 2011 in one system have actually appeared in 2010 and were detected by another system. So by merging the two, we don't really eradicate that problem, but it kind of improve our data and hopefully also detect a bit more of the effect that we would like to see. The other problem we had is that not all of the police officers were well trained in using their GPS device. So some of them took points in the Atlantic Ocean, and some of them took points in Peru and Bolivia. So we had to sort out and find and make sure that the points we measure are actually the points that were taken. And we came up with a division of about half of the points being well measured, and the other half of the points we could only say in which municipality they took place. So there are about 700 municipalities in the Amazon, and this is where we have fines more or less distributed equally across some space that we can't really differentiate, and these are all the other fines that we have actual detection points for. So this is kind of confounding effects that we have to control for in our analysis. I'm not going to be able to explain how we did that, but you have to just believe me that we did it correctly. So here's what we did in terms of matching. These are all matching covariates. So to imagine we have used data on the property status, average property status in municipalities, the distance of one of those pixels to the next town. We use some spatially lagged indicators because there's spatial correlation involved. We use the cloud data from past years and from the actual years. And we use the accumulated deforestation in a given pixel and data on what kind of property regime is underlying in a given pixel. So you can have a settlement, you can have a protected area, you can have a high level of titled private land or not. So all that kind of stuff is controlled for. And the red dots here show you the difference between the treated and the non-treated pixels before we did the matching. And the gray and black dots show you difference between the treated and the non-treated after the matching. The black and gray is just different approaches to matching, but they really don't make a big difference. And it overall looks pretty balanced, so we could sort of throw out the most different non-treated cases from our data set so that we end up with a pretty well-balanced set of treated and non-treated pixels with more or less similar characteristics. So this is just a series of matching analyses that we did using different specifications of data. So when you see ATT, this is the average effect on the treated. This is the effect we want to see. Yeah? And if we throw in all the cells in the analysis, we get a negative effect. This is about 2 hectares. Yeah? One fine would reduce deforestation from one year to the other by about 2 hectares in a 400 square kilometer grid cells. But this is not significant. So what we did is to gradually improve the analysis, for example, by throwing out neighboring cells. So why would we throw out a neighboring cell? Because a fine in one cell could basically affect behavior in a closely neighboring cell. So when we throw out these neighboring cells that would otherwise be in the control group, we get a significant effect of about 4.3 or 4.4 hectares from one year to the other. If we then only look at fines that were specifically for deforestation, we get a much larger effect. You have to imagine that some of these fines are for illegal logging, some of these fines for illegal hunting. I would expect to have those fines to have some effect on deforestation behavior, but not as much as a fine that was particularly for deforestation. So then we started to also only look at pixels where there were no clouds to make sure that it's not just the clouds that govern our story, and the effect gets even larger. And then we try to sort of change and look only at large-scale deforestation, patches larger than 20 hectares, and small-scale deforestation. And here you see sort of a positive but non-significant effect. So that would be, if that would be significant, we could sort of hypothesize and say, well, it's probably possible that there's some kind of avoidance behavior. But the big effect is definitely with the large-scale deforestation, just the way it has been suggested by some of the other papers. Okay, this is just, again, I'm finishing. This is just, again, the same analysis using the share of the size of deforestation, but it's not significant. So we don't have a lot of good arguments to argue for avoidance behavior, but we do have good arguments to support the hypothesis that the fines are actually working. So one fine reduces approximately deforestation by 10 to 20% from one year to the other. We have some problems which are related to clouds and imprecisely measured fines. And we still have to do some tests on whether these analyses are really all robust. But in general, what you can say is that even in this period after the big drop in deforestation rates, so from 2009 onwards, it's more or less stable, and these fines do still have a significant effect, and they're probably one of the big reasons why deforestation is being kept at low levels. But the reason is not actually the fine itself. It's all the things that are associated with the fine when you get it. So you may not have to pay it, but you get problems in getting credit, you get problems in selling your stuff to the slaughterhouse or to the sawmill. You may get problems in getting your land parcel titled. So all these things that are associated with a fine actually affect someone who is given out a fine, even if he doesn't have to pay it. You know? So we can't find any significant evidence for this avoidance behavior. It might just be that the big guys really stopped deforesting that much and the small guys continues because they are not as controlled. But what's kind of encouraging is that we did a bit of economics here and tried to come up with the cost of how much does it cost to give out one of those fines, and it's about 4,600 reais, or half of that in dollars is the cost of applying one fine in an average location in the Amazon. If you calculate this in terms of carbon emission equivalents, then it's still sort of in the range that you can easily pay for. So it's worth doing it, and it's probably much cheaper than many of the other measures that you could adopt to reduce deforestation. Next question would be, okay, how do you combine this with other policies? And there are many other policies Brazil is trying to implement, but that's for the next SBSTA meeting in a year or two from now. Okay. Good. Thanks.